Assalamualaikum, my name is Umu Farhana. Today me and my team will be present for our lab 1 which about the design and operational characteristic of programmable logic controller system. First, first of all, I would like to introduce our team members. First one is Muhammad Yusri bin Harizan, Nurul Hanis Arisha binti Rostin, and me myself Umu Farhana binti Asmazaris, and the last one is Shazwan Arif bin Saari. I will take a minute for explaining a little bit for this lab 1 and PLC. So what is the PLC? PLC stands for Programmable Logic Controller. They are basically used to control automate system in industries. Okay, they are one of the most advanced and simplest form of control system which are now replacing hardware logic relays at a large scale. Before getting into details about PLC, let us know 3 reasons why PLC are being widely used this day. Okay, first, they are user-friendly and easy to operate. Second, they eliminate the need for hardware relay logic. The last one is they are very fast. So for the lab, it is consists 5 exercises that we need to design based on the question given, which about the conveyor motor that can be moved to the right and left in auto or manual mode, but for auto mode, it is only can be moved to the right. And the required for this lab is to produce a timing diagram, flow chart, wiring diagram, and the ladder diagram. So we used CX program to design the ladder diagram. So today me and my teammates would like to show you the step how to use software and also the design by the question. So Shazwan will explain furthermore about how to using the CX programmer. Thank you.
Thank you to Umu Farhana presenting about introduction just now. Okay, Assalamualaikum. Let me introduce myself. My name is Shazwan Arif bin Shahari. And now I will present how to use CX programmer which I have learned with Sir Sharudin. Okay, so first of all, you open the CX programmer. After you open CX programmer, your screen will be like this. If you can see on the top left, have an icon like a paper. The icon like paper make a new program. So we make a new program. For device type, we choose CG to M and click OK. Okay, for the input, we're using the new contact, and for the output, we're using the new coil. Okay. We make a new contact here. We put on this bar, and for the value, we put 001. In the command, we just to put input, and for the output, we click on the new coil and we put beside the input, and the value for the output is 101, and we just put output. Okay, so the finalized will be like this. And then we turn on this program using this icon and click yes. So we turn on, it will be line green like this. So we transfer data to PLC. Why I want to transfer the PLC? Because when we post on this input on this camera, will show us the light will turn on. So we transfer first. Yes, yes. Okay, after we transfer data to PLC, we force on this input. And see the light on the camera will be turned on. When I pause off, it will be off. So this is how to using CS programmer which I have learned with Sir Sharudin. Thank you. Okay, after we done the tutorial about CS programmer, we move on to exercise 1, jogging the conveyor motor. So using the simulator push button 0.2, you should be able to jog the conveyor motor to the right, and the output for 8.5. We put the input and the value is 0.2, and the input we look at the figure, 0.2 is T jog right. Right. Okay, after that we make the output. The output is value is if you can see 8.5 because we're not using 8.5 because it's starting from 101, 102, 103, 104, 105, 106, 107, and 108. So 8.5 is 108. And the command we put the conveyor right. Okay, next we using the simulator push button 0.3, you should be able to jog the conveyor motor to the left, and the output is 8.6. We put a new output, value is 0.3. The command is the left, and the output 1.09. And the command is the conveyor left. We online this program. That's it. Before if both push button are pressed simultaneously, then the conveyor motor may not start in either direction. So the question one, when we show you, when we force on this input, on and not transfer to PLC bus. When we force on this both input, the camera will show have a two light. The question one, when we force on this two input, the question one, the light will not on. So how we do it? We put new close contact. This one, and we put beside the digit right here. Yeah. The value for the new close contact, we put 0, 0.03, and the command we put digit there. After that we put another new close contact on here, and the output is 0.02, and this digit right. That yeah. Okay, the question one, if we push this button on, the camera, the light will be not turned on. So turn on this first, and wait, I'm not. Sudah tayar, sorry. Yeah. Maybe first on. See, after we push this button on, the camera will show the light will not turn on. Okay, and that's it from for exercise 1. I will pass to Yusri to continue exercise 2.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yusri bin Harizan. Thank you to Pak Shazwan Arif for the explanation for exercise 1. So I continue to explain furthermore to exercise 2 is programming and operating mode selection. So the statement is for the distribution conveyor you are to program an operating mode selection and interlock the manual mode output 4.2 as a additional condition for jogging the conveyor motor. Right. From the statement, the statement giving is a manual have additional condition, but auto didn't have additional condition. So for first point, the system LED Q output 4.1 is turned on using the simulator momentary contact input 0.0. It is turned off using the simulator momentary contact input 0.1 is new close contact. So this question given output 4.1, but we use 1.02. Okay. So let's do it. So the first the question for the exercise 2, we have we must create the system turn on turn off. So we use the new contact and the input 000, and then the name is G system on, because we use input 00 because at the question given using the simulated momentary contact input 00, so we use input value 00. So the output we use keep, because the keep can stay the system, which is we push the push button on, the system is running. So we use keep. And the value for keep 101. Okay. The name is L system. L system. Okay. And then the next point, it is turned off using the simulator momentary contact input 0.1. At this we use new close contact. New close contact. The value is, the input is 0.01, and then the name we put the T system off. Okay. Then we extend the wire to keep right. So the value at the T system off is 001 because second point is given using the 0.1, and then we must use as the NC contact, new close contact. Okay, so let's keep then we turn on, running the conveyor for the system turn on, turn off. Okay. Okay. So this is a PLC Omron. Okay. First, this question is said the system is turned on using the simulator momentary contact input 0.0. So when we push the button, the system is on. So when we push the off, the system is off. So at this moment we must force on, and then at the system on, we push the button on, and then we off again. So the system has been running at the output 101. So we go to second point. Second point is you can pre-select manual mode output 4.2 or auto 4.3 through switch input 0.4 as follow. Input 0.4, switch off 0, manual mode pre-selected. So at this, we name the system turn on off. So at the second, we click the system manual only. Okay, so the question is input 0.4 off, manual mode right. For this, we use 1.02 this output. This output we use 1.02 because at this Omron have a 0.01 until 0.015. Okay, so let's we do it for the system manual. First, use the new contact, and at the input we use 004, and then the name we given is SMA mode. Alright, okay, so And then the second point, given mode 0.4 is confirmed by switch on the true momentary contact. So we must put the momentary contact again at the SMA mode. Okay. So the input given is 005, then enter. Then we given the name is T/MA/MA/. So this is a push button, yeah, push button. So and then the output is 0. Output there is a 1.02. 1.02. The output is 1.02 because at the equation given is output 4.2, but we use 1.02. So we using keep again. Keep 011. Okay. Then the output we put the value or data is okay, we put 1.02. The name is Airman because this system manual. Okay. So the question given is you can preselect manual mode 4.2 or auto mode 4.3 to switch. Okay. So the operating mode are switched off when you change the preselection of operating mode 0.4 or when the system is switched off. Okay. For the close the system manual, we have two choice. When can close at the system turn on off, or we click the one system again. So we use NC contact, new close contact, and the input is L system this. Okay, so we put the L system 1.01. Okay, and then we put one again new close contact for 004. Okay. Then we extend the wire. Extend the wire. Allah. Extend the wire. Okay. So we have two choice for turn off the L manual at this off system or at this SMA mode. Okay, so now we see we online the PLC. Okay, kita put data. Push the button yes, and then okay, now I want to on the system manual. Okay, so this we on, we push the button on, and then we off. Okay. So at this we must push the button on, and then we push button on and off again. Okay, so the system manual has been progressed or on, and you see the input for system 1.01 is bright, and then for system manual at the 1.02 is bright, is light. Okay, so we must off the system manual only at this we push off, and then the system manual is off. Okay, so another one and another option, we can off the all system at system turn on turn off. So I push button off, push. Okay, so two system as off. Okay, so the next question and the next point, given input 0.4 switch on, 1 auto mode preselected. So we fit for the system. Okay, system auto. At the system auto, we use the L system at the front. L system, and you use new close contact. For the value or data for input, we use 1.01 because at the L system is 1.01 at this. Okay, so we use for the mode SMA mode, new close contact. The input is 004 because we have script at the system manual. Then we use the push button, and then you put the push button. Push button is 005 or TMA accept. Then for output is for another one. For another one, yang kali jangan masuk macam tu, tak aku bunuh lah. For another one kat tu. Okay, tu kedua. So for another one, we use so for another one, okay. So for another one, we use new close contact for SMA mode 004. Okay. So the output is 103, and then the name is L copy. Why we use output 1.03? Because at the question given is LED Q4.0, but we use 1.03 at the question is 1.03. Okay, so we must put the system for closed system auto only. We must put this L auto, and then 1.03 at then So let's we see at the camera online the CG2M, transfer the data, okay, see okay, we on the system, on, then off, push on off. Okay, so at this system difference, the system auto difference, manual and auto is different. So at the auto we go to the accept, just we must accept the box on, and then tada. Alright, so we push button this, and then the lamp at auto is on. Okay, so we close the system auto, we force, and then we off. Okay, the system, all system is turned off. Okay, right. So and then we next to the next point is the operating mode are switched off when you change the pre-selection of the operating mode input 0.4, or when the system oh sorry saya soalan kau potong tu Wan. Okay, next okay, so for the next question is integrating the manual mode Q4.2. Okay, the question given is the job conveyor motor program previously program is now only to be possible when the manual mode switch on program. The relevant log out in previous program must be modified. Okay. Alright, so at this okay, so one, faham balik aku terpaksa di kau punya ni sebab overlap. Okay, so kita ulang balik okay, 1, 2, 3. Okay, for the next point is integrating the manual mode Q4.2. So the question given is the job conveyor motor program previously program is not only to be possible when the manual mode is switched on program, the relevant log out in the previous program must be modified. So at this question we use the interlock. Okay, so because at the previous exercise 1, the conveyor should be run to the right when the system manual is on. Alright, so at this we put the name is integrating the manual mode. So firstly we put the L system, L system is 1.01, and we put the element is L manual as 1.02. Okay, L manual. Then we use the interlock. Is it right? We use the interlock IL 002. Okay, so at the second rung we use the exercise 1. We must put the exercise 1. Okay, so put the digit right 002, then put the new post contact 003. Okay, so we put the output is 10 because we use the internal delay. So the internal delay is 10, right? Okay. And then this name is manual write. When we open the manual, the job conveyor is run to write. Okay. So we put the left at the third rung. Sorry, we put the second is 003, job left, and then NC contact 002, right, and then the output is 109. Okay. So this we must use the interlock clear, because at the up we use interlock. Okay, so we use the interlock clear. ILC 003. Okay, this is wrong, right? So we cannot do it this. So we troubleshoot. Again, we must put the wire. This is wrong. So we must troubleshoot because we use the one rung. It cannot use the one rung. So we troubleshoot this, and then we use another rung. And then we put the interlock clear 011. Is it right? No, we put 003. Okay, so cara, and then we must sambung the wire. Okay, so this question given when we on the system manual, the conveyor must on at the same time at the right. Okay, so see the camera, and then we online the PLC, right? Online the PLC, and then we transfer the data. Okay, so okay. Okay, so we must all right. Okay, so we open the system. We turn on the system. Okay, turn on the system. Okay, so the system is on. The system conveyor is on, but it's not right. Okay, so we open the manual. When we turn on the manual, the conveyor is jobs, right? Okay, so we accept on, then we accept on, push the button on. Okay, off again. So we must push the button. Okay, ta-da! So the output cannot be invisible. Yeah, cannot invisible. Cannot. Okay, so the output is internally, so not like because the Omron have until the output until 15 only. Okay, so okay, so this is exercise 2. So I pass to Hanis to explain about exercise 3. Okay, thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Hanis Aisyah. Thank you to Yusri for explaining about exercise 2. Now I'm going to continue to exercise number 3. In exercise 3, we use conveyor in auto mode. In auto mode, parts are to be transported from bay1 or bay2 to the final check or light barrier. So, if we look at the condition for run conveyor right start when bay 8.5 proximity sensor is occupied and not bay 2. 8.6 proximity network in occupied, and bay 1 momentary contact is pressed, or bay 2 8.2 proximity sensor is occupied and not bay 1 8.5 proximity sensor is occupied, and bay 2 8.2 momentary contact is pressed. So what it means is we're supposed to transport an item from bay 1 or bay 2 to the final check or light barrier. So first I will include the input for bay 1. If we look at the conveyor model, we will find out the true input. So for bay 1, we use 0.10. Okay, next since the condition as for n not bay 2, so we use normally close for bay 2. The input is 0.11, and bay 1 momentary contact is pressed. So for bay 1 momentary contact is 0.06 for T bay 1. Okay, next or bay 2 proximity sensor is occupied. So for this part we put normally close for bay 1. And 0.07 for T bay 2. So this line and this line should be different from each other. So we connect it with keep. So we put keep here. For keep is okay. For next condition is run conveyor right is stopped when the part has reached the final check position for the light barrier, or auto mode is switched off. So for the light barrier, So for light barrier, the input is 0.13. So we connect it with L auto because we use run conveyor auto. So for L auto is then we connect it to the kit. Okay, since question 3 we want to use run conveyor, right? So we have to add one more condition, which is we have to add on this manual, right? So we have to add one more condition. We use and we name it as auto. So we connect it with new output. Conveyor. So let's see how it works. First, we need to off this. Turn off the system off. Force on. Since we want to use auto, so we accept from the system auto. So B1 sends the item and TB1 sends the item. So the conveyor right will turn on. So if LB it reached to LB light barrier, so the conveyor will turn off. Or if we switch off the auto mode. Okay. How it works? First, we need to force on this system off. then we need to system on. When since we use auto, so we need to accept this system auto. So first, B1 will detect the item. Then TB1 will detect the item. So the conveyor right will on. So how to turn it off? So the conveyor will turn off when it reach to light barrier. Or the other way around, it will turn off when we switch on the auto mode.
Okay, so let's look how it will work. First, we need to work it online. Then we will transfer it to PLC. So before we start, we need to turn on the L system. PLC system is on. So we need to, since we use push button, we need to twist on like the T system on. So since we use auto mode, we need to accept the system auto. Then bay 1 will sense the item. So we need to turn on the bay 1. The bay 1 will also detect the item. So the item will run to the right conveyor. So right conveyor right will turn on at 1.08 output. So we will turn off the bay 1 and bay 1. So the question asks, run conveyor right in stop when the part has reached the final check position or the light barrier. So when the item has reached the light barrier, so the light and the conveyor will off. When it reach the light barrier, supposedly the light will turn off. Or the other condition is when we switch off the auto mode, also the right conveyor will turn off. Or for the second condition is the auto mode switch off and the run conveyor right will stop. So we will use bay 2 this time. So we turn on the bay 2 and the bay 2. So the conveyors turn on after they detect. So we will turn off the auto mode. So the auto conveyor have turned off. So that's all from me for question number 3. Thank you.
Okay, Assalamualaikum. So I will continue for exercise 4, which is integrating the age detection. So for question 4, it is use a function differentiate 30 and 40. For the instruction differentiate 30, will change the output state to on when the input signal change from off to on. Okay. For the instruction differentiate 40, we change the output state to on when the input signal change from on to off. So we will use this instruction for the exercise 4. So basically for exercise 4 is actually same for the question 1 and 3, and the part to be off also same with the question 3. Like you see right now, the point 2 and the point 1 and 2 is same with the question 1 and 3. Okay. So but But what is the difference can for the exercise 4? So for exercise 4, it is actually the question 1 to the conveyor motor in auto mode is to remain fundamental unchanged. However, the conveyor motor is to be stopped as soon as the part has passed through the light barrier. Meaning that before this, for question 3, the conveyor right will stop when it reach to the light barrier, right? You see, the conveyor right is stop when the part has reached to the final check. But on the exercise 4, it is unchanged. The question 1, the conveyor right stop as soon as the part has passed through the light barrier. So meaning that if the conveyor motor move to the light barrier, it will stop. Okay, but the light barrier would not detect. Okay, so we change the name. LB has age trigger negative age. So I will use the internal delay output for the negative age. Okay, so I will use 10.02. I change because in a question in exercise 4, I will use the LB. Okay, so I will take the new contact. The LB 0.13. Okay, LB, and then we will use the instruction differentiate 40. Okay. Okay, so so the output I will use 10.02. Okay. So is now question 3 will stop when the conveyor reach at the parts when it will stop when it reach to the light barrier, right? But for the question 4, it's unchanged, fundamental unchanged, meaning that we assume like the item is falling down to the ground, fall to the ground. Okay, so let's try. Okay, we on the online mode. Okay, and then we transfer to PLC. Okay, so this is in auto mode. Okay, so we switch on the system. Okay, on. And then we on the auto mode. And then we use the B1. Okay, so the conveyor will stop when will be stopped as soon as the part has passed through the light barrier. Okay, so this. Okay, it's already passed to the light barrier. Then automatic the conveyor will stop off. Okay, you see, the conveyor will stop. So that is the for the question 4. And then I will move to the exercise 5. So I will show you how the light is turned on the run. Okay, so first thing first, I will turn on the online mode. Okay. And then I will transfer the file to PLC. Okay, then this is for the question 4. So we need to waiting for the transfer file. Okay, so I will turn on the system. Okay, so for the address 1.01, the light will turn on. Basically, as you can see here at the camera, our Omron, the light is turned on. Okay, so I will choose the auto mode for this question. Okay, so for the address 1.03 we turn on. Okay, and then I choose to make a force to B1 to detect the items in auto mode. I will turn on. So the conveyor right will turn on for address 1.08. Then I will turn off the push button because the item would not be detect because the conveyor right it's already moved to the right. Okay, so basically the question 4 we need to turn off when the item pass as soon as pass through the light barrier. Okay, meaning that we assume the item is falling down to the ground. Okay, meaning that the light barrier would not detect the item. Then after pass the light barrier, the conveyor right will be stopped. Okay, so I will show you how it could be. Okay, so when I push the light barrier turn off, the system will automatically switch off. Okay, so before that we must turn on. Okay, and then we turn off. You see, the conveyor right, the light at the 1.08 will turn off for the conveyor right. So that is the result for the exercise 4. Thank you. So I will be continue for exercise 5, which is putting indicator lights and horn into the operation. The indicator light at B1 and B2 as well as the horn to be controlled as follows. So for the exercise 5, we will use auto mode. Is switch on the indicator light shows. Okay, for exercise 5, it is consists 3 terms, which number 1 is constant light when a new part can be placed on the conveyor. Conveyor motor is standing and both proximity sensors are free. Okay. The second term is 1 Hz flashing light at the bay where the associated proximity sensor detect a part and only so long as the conveyor has not yet been started. Okay, and the third term is 2 Hz flashing light as long as the conveyor motor is moving. Okay, so we will design the 3 terms. So I will make a name for this exercise, which indicator light to the operation. Okay. And then I will start the design. So I will actually we will use this design, but in a different type of shape. So for the exercise 5, I will start with a new close contact for B1, which is 0.10, and then I will continue for the B2, which is 0.11, and I will make a new one which still using a new close contact. The input is 1.07. I name for this input is bay conveyor rack. Okay. Then second, I will use a new contact, also B1 0. I will continue to 1 Hz. Okay. So this the question asks me to using 1 Hz. So 1 Hz is 1 second. What 1 second? Okay, 1 second. Okay. No. Sorry. 0.1 second. Okay, it should be 0.1 second. It's 0.1 second. And then I will be continue using new close contact. Connect with the input bay conveyor right, which 1.07. And then the third, we use the third terms. We use 2 Hz. To get to 2 Hz, we must use 0.5 second. So to get the 0.5 second, we will use the new contact and we choose the 0.2 second. Okay, and then same 0.2 second. If I'm not mistaken. Okay, yeah. And then a last one, 0.1 second. To get 0.5 second. It's same with for 2 Hz. Okay. And then we connect with the bay conveyor right, which 1.07. And then B1. B1 I will use new close contact also. 0.10. Okay. And then these three terms we connect with the auto mode. Okay. So for the auto mode, we use new contact. Okay, new contact 1.03. The output we use LB1. So this is I make for LB1. Okay, the output 1.04. Okay. So we rearrange, put here. Okay. Then we connect, and then oh. Okay, so this is only for B1, and then we will design for B2. Okay, it's actually same the design, but I put the the auto mode at the front of the design. Okay, so 1.03. And then same, just follow it's same design actually. Okay, how we take this new post contact for B1 0. And then we move to B2 0.112, and then for B conveyor right, it's also same 1.07. And then here we use a new contact for B2 0.1. Then this is for the second terms, 1 hertz. So we will use 0.1 second. And then we connect with the push button B conveyor right 1.07. And then we will start design for the third terms, which is 2 hertz. We use this. We put 0.2 second, and then use contact 0.2 second, and the last one is 0.1 second, and then the push button for conveyor right, B conveyor right. Okay, 1.07 and B1. 0.10. Then we will connect all of this with the LB2. Okay. We use output. We put here 1.05. It's LB2. Okay. And then we connect the that is for the LB1 and LB2. Okay, to see the bay conveyor right move, so we use input 00008. Okay, and then the output we use 1.07. So why I make this, because when the flashing light, this is the conveyor that we can see it is moved to the right, okay, for the bay. Okay, and then okay, we can try to see the result. So we turn online mode. Okay, and then we transfer to the PLC. Okay, so when I turn on the auto system, the terms number 1 will be shown at the design, okay, at this design. Okay, so I will turn on the auto system. On, then okay, off. Okay, then I will use the auto mode because the question wanted us to using in auto mode. Okay, you see from here, we already prove for the terms number 1, which for the bay 1 and bay 2 is constant light. Okay, so the terms number 1 we pass. Okay, so we will try for the terms number 2, which 1 Hz flashing light at the bay where the associated proximity sensor detect at a part, and only so long as the conveyor has not been started, meaning that only the bay 1 will flashing using 1 Hz flashing. Okay, but the conveyor didn't start yet. Okay, so I will try use for 1 Hz. So I will turn on this. I will force on to make it proof for the terms number 2. So if you see here, only bay 1 is flash the light, but but the bay 2 is not. So it is proof for the terms number 2. So we move to terms number 3, which the 2 Hz flashing light as long as the conveyor motor is moved. Okay, so I will turn on this conveyor motor, this input to move the conveyor motor, and when the conveyor motor is moved, it will be flashing at the bay 2 using a 2 Hz flashing. Okay, so I will turn here, pause. So you see, it is proof. So Alhamdulillah, for the third terms, we already proved that only B2 flash using 2 Hz. Okay, so that is the question number 5 for the point number 1, number 2, and number 3. And the last one is the horn. Okay, so we stop the online mode. So I will continue the horn. We will put the horn. Okay, so the horn sounds will with a 2 Hz pulse tone if the conveyor motor is jogged to the right or to the left in a manual mode. Okay, so for this horn, we will using in manual mode. Okay, the design will be like this. So the question asks me to use the 2 Hz. So we will use the new contact 2 Hz, so 0.02 seconds, and then we continue to 0.2 second and 0. Wait. No. Sorry. It's not a 0. It's not a 0.0 second. Sorry. It actually should be. It should be 0.2 seconds. Okay. Sorry. It's also same for this. 0.2 seconds, and then we continue to connect with 0.1 second to get the 0.5 second. Same for the 2 Hz. Okay. Okay, and then we will put the input contact for L manual, which 1.02 L manual. Okay, and then we will connect for the jog left or right, because the question give us two option, which is the right and also the left. So we will put the contact for T jog right, which 002. Okay, and then or T jog left. T jog left, the input address is 003. Okay, and then the output. So for the output, we will put the horn. So basically, if you see at the figure, oh my god, sorry, at the figure, the address for horn is 8.7, but we not use that address. We use for horn address is 1.10. Okay, 1.10. So that is the horn. Okay, so we will be connect. Okay, connect. So that is the design for the question, the last question. So I will try. Oh, I forgot to put a name. Okay, in the horn into the operation. Oh my god. Okay, so I will test and I will turn on the online mode. Okay, and then I will transfer to the PLC. Okay. Okay, so Bismillahirrahmanirrahim. We turn on the system. Off and we on. Then we off back. Okay, for the question, the question asks we to use in our manual mode. So we will turn on the manual mode. So on. Okay. Then we turn off back. Okay. So okay. If you see you see now at the design, we just need to choose whether T-job right or T-job left. Okay, but yeah, the 2 Hz flashing light is already flashing, but before that we must decide whether we want to use right or left. Okay, so we just turn on. Okay, I wanna use T-job right. Okay, so I will force on. Okay, you see the horn will come out the sound. Maybe I don't know how the sound is. Maybe it's like okay. So the sound will be come out with the 2 Hz flashing. So it is already proved for the question at the last question. So that's all for the exercise 5. So this is the design. It has a flashing light, indicator light that we put. We use 1 Hz and 2 Hz, and also the horn we use in manual mode, and the light is using 2 Hz, and this part we use in auto mode. So that's it. Thank you. So I will show you how the light is turned on based on these 3 terms. Then I will try to prove to you that is the three terms can be turned on the light on the Omron. Okay. So first thing first, I will turn on the online mode. Okay. And then I will transfer the file to PLC. Okay, so I will turn on the system. Okay, so for address, for the L system address 1.01, it will be turned on, as you can see here. Okay, and then I will choose auto mode, because in exercise 5, the question asks me to use in auto mode. So the address, the output 1.03 will turn on. Okay, here I guess, and then the bay 1 and bay 2 will be turned on also, because it is automatically, because we already turned on the auto mode. So, and here we use new contact close, so the force automatically flow to the auto mode, and then the bay 1 and bay 2 will constant light. Okay. So for first term, it's already proved. And then we move to second term, which is 1 Hz flashing light at the bay. But at the bit. Okay. So I will turn on. I will give force to this B1. Okay. So I don't know why it cannot see clearly, because I think lab not switch on the lamp, so we cannot see properly here. But if you can see right now, have a bit flashing, but we don't know which one address. But it should be on address 1.044, okay, at the B1. So second terms proof. So we move to the third terms, which is the 2 Hz flashing light as long as the conveyor motor is moving. So we need to give a force to the conveyor, right, to move, and then the 2 Hz will flashing the light. Okay, so I will turn on. Okay, so yeah, here 1.05, it is a B2, and then 2 Hz is it's already flashing when the conveyor right is moved. So these 3 terms, it's already proved, alhamdulillah. Okay, so we move to the last one, which is the horn, but we need to change in manual mode. Okay, so we turn on. I try. Okay, we try to switch off. Okay. Okay, we off this. Okay, so the last question, they asked to use manual mode, so we change to a manual mode. So we turn on to manual mode. Okay, so automatically the auto mode will turn off. Okay, then we accept to turn on. Okay, manual mode is on. Okay, at the address 1.02. Okay, and then I will turn on the manual right. Okay, so the manual right will flashing. Okay, so it's already turned on the T-jog right, because we already turned on here. So at the bottom, because this is the contact that we use again for the exercise 5. That's why when we turn on at the top of the push button, then automatically at the bottom will turn on. Yeah, okay, turn on. So we use T-jog right. So the horn will come out the sound, but I don't know how the sound it goes. So the horn will be at output 1.10. We use T-jog right, and we use in manual mode. Okay, I don't know how the sound, maybe like like that, I think. Okay, so yeah, for question for the exercise 5 is done, and I already show you how the light is turned on based on our Omron. So thank you.
So, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yusri. Thank you to Hanis for her explanation. So, I continue to explain about wiring diagram. So as you can see from screen, this is a wiring diagram. Wiring diagram, we use the wiring diagram have a two port. It is input card port and output card port. Okay, for the first port is input card port. So input card port we use 0 volt and connect to the T system. T system on, T system off, SAMOD mode, TMA accept, T jog right, T jog left, TB1, TB2, TB1, TB2 and LB. So we use the input and output from the table at the left screen. So the input card 0 volt. For T system on, we use input 0, and then T system off, we use 0, 1 for input, and SAMA mode we use 0, 4 at this 0, 4. Then TMA accept 0, 5, T jog right 0, 2, this T jog left 0, 3, TB1 0, 6, and TB2 0, 7, B1 1, 0, B2 1, 1, and also LB 13. So this is a input card port, and then we move to output card port. Output card port have a 9 output we use. For the first, we have connect 0 volt to COM, and then 24 volt to output device. So we use LC2, L-Auto 03, LB1 04, LB2 05, B convey right 07, K convey right 08, K convey left 09, and manual right and auto right and negative edge is a internal delay, so we not put at the output card because we not have a 10 for the output. So we next to horn, it is 10 0 10 for horn. Okay, so that's Hai, Assalamualaikum warahmatullahi wabarakatuh. Thank you to Shazwan, Hanis and Umu for explanation about exercise 1 and until exercise 5. Now let's move on to how to produce the timing diagram from CS programmer software. Okay, now you must click the tab PLC. At the tab PLC, you move to time chart monitoring. Okay, so you click the time chart monitoring, and then one workspace with one workspace is a PLC time chart monitor. Okay, so at the workspace this, you must change the configuration at this. You click and then you change the fixed interval to 300 and number of sample 150, and then after that you must change the test object. Okay, at this test object you must include the input and output. So at the now I want to produce the timing diagram for system mode manual. Alright. Okay, so this is a manual system. Now we use the system on 00, the address 00, L system 101, and then SMM mode 004, team MESAP 005, 102 for L manual, 10 for interval delay is manual write, then okay, convert write 108. Okay, convert write 108. Okay, so now I want to click OK, and then after that you must online the CS programmer to Omron. Alright. Okay, and then click the data transfer. Click the data transfer. Then click yes. Okay. Now. Okay, so now for produce the timing diagram, we must click the execute this. Okay, now I will invite Umu to push the button for manual only. Okay. Umu ready? Are you ready?
Yes.
Okay, now I click the button execute. 1, 2, 3.
So that is how I produce the timing diagram for manual mode. So we can move to the timing diagram. Can you stop the timing diagram, Yusri?
The timing diagram is stopped automatically. Alright. Okay, now the timing diagram is stopped. Okay, so I would like Umu to explain about the timing diagram.
So the timing diagram, as you can see just now, I turn on the system the system on. Okay, when I turn on and the flow will go up has a 1, and when I turn off the system, but the system still available, I just want to turn on, then will go down has a 0, and then I give a push to the L system. So this is the push button for system on. Then when I off the push button system on, then the system will still going the flow for the L system, and then I will give the force at the input 0.04 and then I will accept with the push button 0.05 to on the L manual, because right now we want to make a manual mode. Okay, and then after I accept, I will push on the T jog right in manual. Okay, when I turn on the T jog right, the conveyor the horn will automatically open, because just now I already turn on, or I already give the force at the L manual and also the T jog right. So this is how the timing diagram looks. Okay. So this is how the way the horn looks like in timing diagram. Okay. So this is the timing diagram for manual mode only. Thank you.
Now I want to produce the timing diagram for the system auto mode. Okay. Now we must change at the configuration, test object, and then this object must change to auto mode. Okay, firstly we use system on and system SM the ASM L auto LB1 LB2 TB1 auto write. Okay, copyright LB negative H LB1 LB2 M write B copyright T jot. So this is input output for system auto mode. Now click OK. Okay. So I just link this to the Omron. Okay, and then I transfer the data to the PLC. To the PLC. Now I would like invite Farhana to push the button for the system auto mode. Before that, I want to link or online the PLC to and then transfer the data to Omron. Right. Now we wait to the transferring. Okay, now push OK, and then click yes. Okay, now Umu, are you ready, Umu, to push the button for the automate system?
Yes, I'm ready.
Okay, you ready? Okay, now I push the button execute, and Umu push the button for system automate. Okay, 1, 2, 3.
So I will turn on the auto mode. Okay. I will choose B1 to turn on the auto write. Okay. The system. Okay. I will turn on the B conveyor write. Okay. So that is how I produce my timing diagram for auto mode. Yusri, can you stop the timing diagram?
Okay. The timing diagram is automatically stopped. Okay, wait. Okay. Now I will invite Farhana again to explain the timing diagram.
So for the timing diagram, first thing first that I do is turn on the L system. Okay, so when I give the force, turn on the L system, it will go up. Okay, has a 1, and then I need to off the push button on. Okay, but then L system still go up, has a 1, because when we didn't turn push button turn off, the L system will continue the process, the L system. Okay, and then this is auto, so I will push the button accept, because this is auto. We didn't have to give additional condition to the MS mode. We just directly push the button accept to on the L auto. Okay, and then I choose to B1 to give auto write to make in to start the process of auto write. So I choose to B1, and then I push push button B1 to make a K conveyor right move to the right. Okay, basically as we know that only auto can move the conveyor right, but for manual can be both right and left. Okay, so after I push the push button B1, I will turn off back. Okay, and then automatically the B1 and B2 just now if you see it's already turned on. Okay, then I turn on my input 0.08. This is additional input for me to see the bay conveyor right move. So this is the last step I make, and then that is how the flow for the auto mode, because auto mode didn't have the horn only have on manual mode. Okay, and then as you can see, after I do all the direction or give the force to the push button, to the input, and so on, then the timing diagram will be produced like this. Okay, as you wish. It's like when you push, then it will turn go up as a 1. When you push off the push button, then will go down as a 0. So this is the timing diagram for auto mode. Thank you.
In conclusion, Programmable Logic Controller PLC language is an industrial digital computer that has been ruggedized and adapted for the control of manufacturing processes such as assembly lines, robotic devices, or any activity that require high reliability, ease of programming, and process fault diagnosis. PLC helped us a lot on developing the design of conveyor motor. The project helped to develop the knowledge that are useful for future industrial training. This is simple to understand, but it is complex program that run in the ladder diagram that might be difficult. However, for users that always use this program might be more understand. Hence, by completing this task, we are able to understand more of PLC programming, ladder logic, and familiar enough with a variety of ladder logic instruction to develop a PLC program, for instance, Omron. For the recommendation, we anticipate to learn more about Allen Bradley PLC because their software comes with control logic, controllers, and software, guard PLC, and soft logics software, since their network of controller can manage a whole plant with an appropriate plan and design. Instead of that, the company offers controller for small size application like SCL 500. We also hope that we can explore more about Allen Bradley, Omron, and other PLC that allows us to contribute more in engineering sectors. That is all from us. Thank you so much.